When installing exterior lights on a commercial building with concrete walls, it's crucial to protect the electrical wiring by using electrical metallic tubing, commonly known as EMT, or another approved method. The primary reason for this requirement is to safeguard the wiring from physical damage during and after the concrete pouring process. Concrete is a highly abrasive material, and direct contact with electrical wires can lead to insulation damage over time. This insulation breakdown can result in short circuits, ground faults, and potentially dangerous electrical hazards. Furthermore, the alkalinity of concrete can degrade certain types of wire insulation, accelerating the risk of electrical failure. EMT Conduit provides a robust protective layer around the electrical wires, preventing direct contact with the concrete and shielding them from abrasion, compression, and chemical degradation. The conduit acts as a mechanical barrier, ensuring the integrity of the wiring system throughout the lifespan of the building. In addition to physical protection, EMT Conduit also offers a degree of fire resistance. In the event of a fire, the conduit can help contain the flames and prevent the spread of fire along the electrical pathways. This can be a critical safety feature in a commercial building where the potential for fire hazards is often higher than in residential settings. When installing EMT conduit in concrete walls, there are several key considerations to keep in mind. Firstly, the conduit must be properly sized to accommodate the number and size of wires being installed. The National Electrical Code, or NEC, provides guidelines for conduit fill, specifying the maximum percentage of the conduit's cross-sectional area that can be occupied by wires. Exceeding the conduit fill limit can make it difficult to pull wires, potentially damaging the insulation and increasing the risk of overheating. The NEC specifies in Chapter 9 Table 1 notes to tables that the maximum fill for conduit is 40%. Secondly, the conduit must be securely supported and fastened to the concrete formwork to prevent movement during the pouring process. This can be achieved using conduit clamps, straps, or other approved fastening methods. The support should be spaced at intervals that comply with the NEC requirements, typically every 10 feet for horizontal runs and closer for vertical runs. The NEC Section 358.30 details the support requirements for EMT. Proper support is essential to maintain the integrity of the conduit system and prevent it from being displaced or damaged during the concrete pour. Thirdly, all conduit connections must be made using approved fittings and connectors. These fittings should be designed for use with EMT and should provide a secure, watertight seal to prevent moisture from entering the conduit system. Moisture can cause corrosion of the wires and conduit, leading to electrical failures and safety hazards. The NEC requires that all fittings and connectors be listed for their intended use and installed in accordance with the manufacturer's instructions. Fourthly, when running EMT conduit through concrete block walls, it's essential to ensure that the conduit is properly aligned and centered within the block openings. This will prevent the conduit from being crushed or damaged when the concrete is poured. It's also important to seal the openings around the conduit with a suitable sealant to prevent moisture from entering the wall cavity. Fifthly, it is important to be aware of the NEC requirements for grounding and bonding of EMT conduit systems. Grounding and bonding are essential for providing a safe path for fault currents to return to the source, helping to prevent electrical shock hazards. The NEC specifies the methods for grounding and bonding EMT conduit, including the use of grounding bushings, bonding jumpers, and grounding electrodes. Grounding and bonding should be performed in accordance with the NEC requirements and inspected by a qualified electrician. Alternative methods for protecting electrical wiring in concrete walls may be acceptable, but they must be approved by the local electrical inspector or authority having jurisdiction. Some alternatives may include the use of rigid metal conduit, or RMC, intermediate metal conduit, or IMC, or rigid non-metallic conduit, or PVC. Each of these conduit types has its own advantages and disadvantages, and the selection will depend on the specific application and the local code requirements. Rigid metal conduit offers the highest level of protection against physical damage and corrosion, but it is also the most expensive and difficult to install. Intermediate metal conduit provides a balance between protection and cost, while rigid non-metallic conduit is lightweight and corrosion resistant but may not be suitable for all applications. The selection of the appropriate wiring method for concrete walls should be based on a thorough assessment of the environmental conditions, the potential for physical damage, and the applicable code requirements. It's always best to consult with a qualified electrician or electrical engineer to ensure that the wiring system is designed and installed in accordance with all applicable standards and regulations. In addition to protecting the electrical wiring, EMT Conduit can also provide a pathway for future wiring upgrades or modifications. By installing spare conduits during the initial construction phase, it becomes easier to add new circuits or replace existing wiring without having to disturb the concrete structure. This can save time and money in the long run, especially in commercial buildings where the electrical needs may change over time. When working with concrete and electrical wiring, it's essential to follow all safety precautions and use appropriate personal protective equipment, or PPE. This may include wearing safety glasses, gloves, and a hard hat to protect against eye injuries, skin irritation, and head trauma. It's also important to energize all electrical circuits before working on them and to use lockout/tagout procedures to prevent accidental energization. Working with electricity can be dangerous, and it's crucial to take all necessary precautions to ensure a safe working environment. Moreover, consider the specific environmental conditions of the location. Northern Illinois experiences significant temperature variations and freeze-thaw cycles, which can impact the integrity of both the concrete and the electrical system. Ensure that the chosen conduit and fittings are rated for outdoor use and can withstand these conditions. Expansion joints in the conduit runs might be necessary to accommodate thermal expansion and contraction, preventing stress on the system. The National Electrical Code addresses wiring methods in Chapter 3, and specific requirements for installations in various environments can be found in Article 300. It is important to also consider the type of concrete being used. Different concrete mixes have different levels of alkalinity and different curing processes, which can affect the longevity of the electrical wiring. Consulting with a concrete specialist can help determine the best type of concrete to use in conjunction with the chosen wiring method. Also, ensure that the concrete cover over the conduit meets the minimum requirements specified in the NEC. Insufficient concrete cover can compromise the protection provided by the conduit and increase the risk of damage to the wiring. Furthermore, plan the conduit layout carefully to avoid sharp bends or obstructions that could make it difficult to pull wires. Use appropriate bending equipment to create smooth, gradual bends in the conduit. Avoid exceeding the maximum number of bends allowed in a single conduit run, as this can increase the pulling tension and damage the wire insulation. The NEC specifies the maximum number of bends allowed in a conduit run in Section 344.26 for rigid metal conduit, Section 352.26 for rigid PVC conduit, and Section 358.26 for EMT. In addition to the physical installation, proper documentation is essential for any electrical project. Keep detailed records of the conduit layout, wire sizes, and circuit information. This documentation can be invaluable for future troubleshooting, maintenance, and upgrades. It is also important to obtain all necessary permits and inspections from the local authorities before commencing any electrical work. Failure to obtain permits or comply with inspection requirements can result in fines, delays, and potential safety hazards. When selecting the appropriate EMT fittings, ensure they are listed and labeled for use with concrete embedment. Some fittings are specifically designed to provide a watertight seal, preventing moisture from entering the conduit system. Using non-listed fittings can compromise the integrity of the installation and void any warranties. Also, consider the potential for corrosion when selecting fittings. In environments with high levels of moisture or chemicals, corrosion-resistant fittings may be necessary to ensure long-term reliability. After the concrete has been poured and cured, it is important to inspect the conduit system for any signs of damage or displacement. Check all connections and fittings to ensure they are still tight and secure. If any damage is found, it should be repaired immediately to prevent further deterioration. Finally, Before energizing the electrical circuits, perform a thorough insulation resistance test to verify the integrity of the wiring system. This test can detect any insulation faults or damage that may have occurred during the installation process. The insulation resistance should meet the minimum requirements specified in the NEC and the manufacturer's instructions. In summary, when installing exterior lights on a commercial building with concrete walls, the use of EMT Conduit or another approved method is essential to protect the electrical wiring from damage and potential hazards. Proper installation techniques, adherence to the NEC requirements, and the use of appropriate materials are crucial for ensuring the safety and reliability of the electrical system. Always consult with a qualified electrician or electrical engineer to ensure that the wiring system is designed and installed in accordance with all applicable standards and regulations. Remember to consider the specific environmental conditions, the type of concrete being used, and the potential for future upgrades when planning the conduit layout. By following these guidelines, you can ensure a safe and reliable electrical installation for your commercial building. Always prioritize safety and consult with qualified professionals to ensure that all electrical work is performed in accordance with the applicable codes and regulations.